In this example, we want to write the equation of the tangent line to the curve f of x equals 3 divided by 1 plus x squared at the point 1, 3 halves. And we are specifically being asked to use the definition here for the slope of the tangent, which is the limit as h approaches 0 of f of a plus h minus f of a divided by h. So first we want to identify the value of a. And remember, a is the x value of the point of tangency, the point where the tangent line is going to actually touch the curve. So in this case, a is equal to 1. And then just a reminder that the y value, which is the output, that is the same as the value f of 1. So if we plugged 1 into our function, the output would be 3 halves. So let's start by inputting our a value for the limit. So we have the limit as h approaches 0 of f of 1 plus h minus f of 1 all divided by h. And then at this point we really need to think about the algebra we're being asked to compute here. So a reminder of what f of 1 plus h is indicating for us to do. This is telling us that we want our input to be 1 plus h. So essentially we're substituting 1 plus h into our function in place of the x. So f of 1 plus h will end up being 3 divided by 1 plus the quantity 1 plus h squared when we do that portion of the limit. Then we subtract f of 1, which again, we could actually substitute 1 in for x in our function, or we could just use the fact that we know the output, the y value, is 3 halves. So f of 1 is equal to 3 halves. And this is all divided by h. So this is our initial setup. And now we want to evaluate the limit. And we would start by trying direct substitution, and quickly we realize that direct substitution won't work because of division by 0. So we have to rely on our algebra skills. And in this case, we want to basically get a common denominator so we can subtract the fractions in the numerator. So we're going to need to multiply my first fraction by 2 over 2. And the second fraction will be multiplied by the quantity 1 plus the quantity 1 plus h squared, all over the exact same thing. Remember, what we're multiplying by is actually equivalent to 1. So we're multiplying the numerator and the denominator by these values so that we can get a common denominator and subtract our fractions. So we still have the limit as h approaches 0. So 2 times 3 will give us 6. Minus, and then I'm going to just go ahead and leave this as 3 times the quantity 1 plus the quantity 1 plus h squared. I'll do this algebra on the next step. All divided by our common denominator, which will be 2 times the quantity 1 plus h squared. And then this is all divided by h. And at this point, this is a complex fraction, and you might choose, instead of dividing this entire quantity by h, perhaps at this point, to make your work look a little cleaner, you might choose to change your division to multiplying by the reciprocal and write this as multiplication by 1 over h. That might clean up your work a bit at this point. So continuing on with our algebra, now we're going to want to simplify the numerator and resist the temptation to do 6 minus 3, because remember, order of operations requires that we work on the parenthesis first, so we're going to need to actually multiply out 1 plus h squared first, then we'll combine like terms and distribute. So that's what we're going to tackle next. So now we'll go ahead and distribute the 1 plus h squared. So 1 plus h times 1 plus h, which will give us 1 plus 2h plus h squared. And you'll notice I'm not going to simplify the denominator, although you could. I'm not going to bother with that because my ultimate goal is to be able to hopefully divide out this h that's in the denominator so that we can do direct substitution. So that's why I'm not worrying about distributing in the denominator of this limit. All right, continuing to do some algebra here and clean this up. We have 6 minus 3 times the quantity 2 plus 2h plus h squared. Still divided by that common denominator, 2 times the quantity 1 plus the quantity 1 plus h squared, all times 1 over h. Now we're ready to go ahead and distribute. Six minus 6h minus 3h squared when we distribute. And finally, we can combine like terms in the numerator. And we notice that the 6's subtract out to equal 0. And what we're left with here in the numerator, both of these terms have an h in common. So we will be able to factor out an h, which is great news because then we can divide out the h that we have in the denominator. So once you factor out an h from the numerator, we have h times the quantity negative 6 minus 3h. That allows us to then divide out the h in the numerator and the denominator. So our final limit here is the limit as h approaches 0 of negative 6 minus 3h divided by 2 times the quantity 1 plus the quantity 1 plus h squared. And now we're ready to do our direct substitution. So when you do your direct substitution, that's the step where you can actually drop the limit, and we're substituting in a 0 in place of every h. And this is why, again, you can see here that you didn't need to distribute in the denominator, although you could have. That was unnecessary since we're just going to do direct substitution in the end. So it looks like we're left with negative 6 in the numerator. And in the denominator, we have 2 times 1 plus 1 is 2, so 2 times 2, negative 6 divided by 4, which leaves us with negative 3 halves. Negative 3 over 2. So remember, this is the slope of the tangent line. And specifically, this was the slope of the tangent line at the point we were given, which was the point 1, 3 halves, if you look back at the original problem. So now that we have the slope and we have the point, then we can write the equation for the tangent line. And I'm going to choose point slope form here, since I have a point and a slope, which would be y minus the y value of our point, 3 halves, is equal to the slope, which was negative 3 halves, times x minus the x value, which is 1. And in my class, I allow students to leave their answer in point slope form like this. However, if you had an instructor that insisted that your answer be in slope-intercept form, then you could go ahead and distribute the negative 3 halves and add the 3 halves over to solve for y, and you would have your answer in slope-intercept form. Now, the second part of this problem asks us to find the slope of the tangent again, but using a different method, this time using the other limit definition for the slope of the tangent. So once again, we identify our point of tangency. The x value is our a value, so a is equal to 1. So we'll rewrite our slope of the tangent as the limit as x approaches 1 of f of x minus f of 1, all divided by x minus 1. And then we know our function f of x was the original function we were given. So we'll go ahead and input that function, which is 3 divided by 1 plus x squared. And we also know the value of f of 1. If we were to input 1 into the function, we would get the y value of 3/2. So we can go ahead and put 3/2 there, all divided by x minus 1. So once again, we're going to go ahead and attempt to do direct substitution and substitute in 1. And right away we notice that that will give us division by 0. So we need to do some algebra first. And we're going to get a common denominator in the numerator. Our least common denominator in this case will be 2 times the quantity 1 plus x squared. So we'll be multiplying the first fraction by 2 in the numerator and the denominator. And we'll be multiplying the second fraction by the quantity 1 plus x squared in both the numerator and the denominator. So we'll have the limit as x approaches 1. 2 times 3 is 6, minus 3 times the quantity 1 plus x squared. This will all be over our common denominator, which was 2 times the quantity 1 plus x squared. And then this is all divided by x minus 1. So at this point, if you want to clean up your work a little bit, and rather than writing this as a complex fraction where we're dividing by the quantity x minus 1, we could go ahead and change our division to multiplying by the reciprocal, which would be multiplying by 1 over x minus 1, if you prefer this for your work. So now we'll simplify the numerator here. And again, our hope is that this x minus 1 is going to eventually divide out, so that we'll be able to do direct substitution. So now you'll distribute in the numerator, as well as combine like terms. So we have the limit as h approaches 0 of 6 minus 3 minus 3x squared divided by 2 times the quantity 1 plus x squared. Once again, you could distribute in the 2, but I'm not going to bother. I'll just leave it factored out. And then combining like terms, 6 minus 3 gives us 3. So we have 3 minus 3x squared. And then notice that there is a common factor in that numerator. So 3 minus 3x squared, we can factor out a 3. So the limit as h approaches 0 of 3 times the quantity 1 minus x squared, all divided by 2 times 1 plus x squared times 1 over x minus 1. So we're super close to being able to divide out the x minus 1. We're not quite there yet, but we do notice that 1 minus x squared is a difference of perfect squares. So we'll be able to factor that into 1 plus x times 1 minus x. So we have the limit as h approaches 0 of 3 times the quantity 1 plus x times 1 minus x all divided by 2 times the quantity 1 plus x squared times 1 over x minus 1. And again, we've reached this point where we're so close to being able to divide out the x minus 1 in the denominator. However, we notice that in the numerator we have 1 minus x. We don't have x minus 1. But remember, 1 minus x, if you were to factor out a negative from that binomial, that would leave us with negative 1 plus x in parentheses. And if you reorder that, that is the same as x minus 1. So we're going to factor the 1 minus x in the numerator, and then that will be able allow us to divide out the x minus 1 in the denominator. So I'm going to factor the negative. I'm going to write it all the way out in front of the 3. So negative 3 times 1 plus x. And therefore what we'll be left with here is x minus 1 because we factored out a negative 1. And finally we've reached the point where we can successfully divide out the x minus 1 in the denominator with the x minus 1 in the numerator. So we've got the limit as h approaches 0 of negative 3 times the quantity 1 plus x divided by 2 times the quantity 1 plus x squared. And finally, time out. I am so sorry. I was just getting ready to do direct substitution and noticed, oh my goodness, I reverted to writing h approaches 0 on these limits. I am so sorry. Mistakes happen. We aren't doing the first limit definition. We were doing the second one. So these should all say x is approaching 1. I make mistakes too. So I apologize. Get back there. Change those all back to x approaching 1. I'm even going to go back a page. Oh no. That's terrible. We'll replace all of those, please. Because we were doing the second limit definition here. All right. Dare I go back one more page? We're good here on our original page. The limit as x approaches 1. Sorry about that. Okay. We are now to the point where we can do direct substitution. We'll drop our limit and substitute in 1 for x. So negative 3 times the quantity 1 plus 1 divided by 2 times the quantity 1 plus 1 squared. So negative 3 times 2 divided by 2 times 2. And sure enough, we do end up with our previous answer of negative 6/4, which simplifies to negative 3/2. And this is the slope of the tangent line. Once again, it's not the slope everywhere. It is specifically the slope at the point we were given, which was 1, 3/2. So we can write the equation for our tangent line in point slope form if you wish. Again, that's y minus 3/2 equals our slope of negative 3/2 times the quantity x minus 1. This is the equation for our tangent line.